We are given a semicircle with diameter AB. Now choose a random point C on the arc and form the triangle ACB like this. Inside this triangle, a circle with center I is placed in such a way that points D, E, and F are the points of tangency to the sides of the triangle. Again, connect these tangency points to form the triangle DEF like this. And the question is, what is the measure of angle EDF? You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let's solve it together. We have told that AB is diameter of semicircle, and we know that according to the angle in a semicircle theorem, that is when any angle formed in a semicircle opposite to the diameter of a circle is always a right angle, or 90 degrees, and diameter of circle is hypotenuse of that triangle. That means this angle C of triangle ACB is 90 degrees, and triangle ACB is right angle triangle at C. Now draw a radius from the incenter I to the tangency point E, and another radius from the incenter I to the tangency point F, like this. Again, according to the radius tangent theorem, that is when a radius is drawn from the center of circle touches a tangent at the point of tangency, then it is always perpendicular to the radius. That means this radius IE is perpendicular to EC, and angle IEC is 90 degrees. And similarly for the point F, radius YF is perpendicular to FC, and angle IFC is also 90 degrees. Now look at quadrilateral IECF. We know that the sum of all the interior angles of any quadrilateral is equal to 360 degrees. And here we already have 3 right angles, each measuring 90 degrees, so the remaining angle must also be 90 degrees. That means this angle EIF is a right angle, correct? Now look carefully, angle EIF and angle EDF are subtended by the same arc EF. And we know that according to the angle at the center theorem, that is, angle formed at the center of a circle is always twice the angle formed at the circumference from the same arc. That means if this central angle, EIF, is 90 degrees, then this angle EDF formed at the circumference will be half of that, which is 45 degrees. So the answer is, angle EDF is 45 degrees. And that's our final answer. Pretty amazing, isn't it? Just a few geometric constructions and some smart use of theorems gave us the exact answer. If you found this explanation helpful and learned something new, do not forget to hit that like button, share it with a friend, and subscribe for more mind-bending math puzzles. Thanks for watching, and I will see you in the next video.